Hello everyone, welcome to our channel Off Campus. Before going into the video, kindly subscribe our channel Off Campus. In this video, we are going to see in differential equation to solve the solution of the differential equation to find out the particular integral and complementary function. Previously, we have posted many videos, almost 40 to 45 videos in engineering mathematics, not in engineering mathematics, and also in not only on engineering mathematics but also in many subjects under ECE, which will be useful for us to, which is mainly focused on competitive exams. Okay, so let's go into the video. So the first one, particular integral, we need to find out the particular integral for the given differential equation. So to find out particular integral, what is the first step? We need to use the RHS type and see the RHS of type exponential type. So RHS is of exponential type. For exponential type, we'll see how to find out the particular integral. Okay, so e power 3x divided by the given f of d. F of d is nothing but d cube minus 2d square minus 5d plus 6. Then what is the next step? Just replace d by the coefficient of exponential term, power of exponential. So what is the coefficient of x here? 3. So replace d by 3 here. Okay. Then e power 3x, substitute 3 cube 27, d squared 9, 2 into 9 minus 18, minus 5 into 3 15, plus 6. What we will get? 27 plus 6 33, minus 18 minus 15 we will get 33. So minus 33 plus 33. See, e power 3x here 33 minus 33, we will get e power 3x by 0. Whenever 0 comes in the denominator, in general, whenever 0 comes in the denominator, what is the value? It is infinity. So it should not be infinity, it is absurd. So we need to do one substitution. Okay, whenever denominator part comes 0, we need to do one shortcut, like so multiply by x in numerator and differentiate denominator. So multiply by x in the numerator and differentiate the denominator, then proceed the same step. We'll see, when we multiplying by x in the numerator, what we will get in here. So this substitution only we will get as infinite value. So here multiply by x in the x e power 3x, differentiate denominator term. Differentiating, what we will get? 3d squared minus 4d minus 5. This is a constant, we will get 0. Now what we need to do? Substitute d by 3, right? Substitute d by 3, what we will get? X e power 3x divided by 3 is already there, 3 square 3 cube 27, minus 4 into 3 minus 12 minus 5. So what we will get? X e power 3x in the numerator, by simplifying the numerical, 27 minus 17. 27 minus 17, 10. So what is the PI for this problem? X e power 3x by 10. X e power 3x by 10, option 4 is the right option for this problem. Then move on to the next one. So we need to find out the particular integral for the given differential equation. So see, whenever we are doing particular integral, we need to look up the right hand side type. This is of exponential type. Exponential type, what we need to do? E power ax divided by f of d term. F of d is the given term, d squared minus 2ad plus a squared. We have previously solved each and different types of RHS, how to we need to calculate the particular integral and all. So kindly check with the playlist. Okay, then only you can get an idea, then only you will able to understand. So now what is the second step? Replace d by a. So replace d by a and substitute here e power ax divided by a squared. See, here. A squared minus 2a squared plus a squared. What we will get? E power ax, a square plus a square, 2a square plus 2a square minus 2a square, we will get 0 in the denominator. Whenever denominator will be, we will get 0. What we need to do? We need to do one some simplification or shortcut, multiply by x in the numerator term and differentiate the denominator term. Okay, this one. So here, so multiply by x e power ax divided by differentiate denominator, what we will get? 2d minus 2a, right? Now substitute, replace a d by the coefficient of this x, d by a. Whenever substituting, see this one, d by a, 2a plus 2a minus 2a, we will get 0. Again we will get the numerator term divided by 0. So we need to do again this step, this shortcut, that is multiply by x in the numerator. So this term 2d minus 2a na, in here x squared, already on x, when we multiplying with x again, we will get x squared e power x. Then differentiate the denominator term, differentiate denominator 2d, we will get 2 only. This is a constant, we will get 0 only when we differentiating. Okay, so this is the particular integral for the given function, x squared e power ax by 2. So x squared e power ax by 2. Option 3 is the right option for this given problem. Okay, we'll solve more problems in this type. Here solution of differential equation, when we previously we have solved only the particular integral. Whenever solution given, we need to find out the complementary function and particular integral as well. So first of all we need to find out the complementary function. So because y equal to complementary function plus pi, that is the solution. When we are adding complementary function and particular integral only, we will get the solution for the differential equation. So to find out the complementary function, this is the f of d into y. So f of d is the given function. To find out complementary function, we need to assume the RHS is equal to 0. Assume RHS equal to 0. Then what is the next step? So what is the next step? To form the auxiliary equation, in short AE. So auxiliary equation, how to form the auxiliary equation? It is nothing but just replace d by m. So m squared plus 2m plus 1. So then right hand side equal to 0. Then we need to find out the roots for this. Okay. So it is nothing but m plus 1 the whole squared equal to 0. Right. Then m plus 1, then we will have two roots, m equal to minus 1 comma minus 1, m plus 1 the whole square. No, so m plus 1 into m, see m plus 1 into m plus 1 equal to 0. We will have two roots for m equal to minus 1 comma minus 1. So see the roots and then form the complementary function according to the roots. So here the roots are real and equal. Real and equal. For real and equal, what is the complementary function? Is nothing but ax plus b or c1 or c2, whatever given in the option. See here constant given as a and b. Okay, so ax plus b into e power this term minus x. Okay, so this is the complementary function. Say it is a equation 1. Then what is the next step? We need to find out the particular integral. To particular integral, we need to use the RHS. RHS is of type, simply they have given one constant as 3. So when we are writing 3 divided by this f of d is the given d square plus 2d plus 1. So d squared plus 2d plus 1. So can we write like this, e power 0x. So anything power exponential power 0 is equal to 1. So it will not, this term will not going to get affected when we write e power 0x. Then what is the next step? Just replace d by 0, right? So whenever d by 0, we simply write 3 alone because it is 1 only. Then apply 0, 0, 0, this term will get 0 divided by 1. So particular integral we will get 3. particular integral equal to 3. So, it is a equation 2. So, what is the y solution? CF plus PA. CF plus PA is nothing but adding equation 1 and 2. Here see, adding equation 1 and 2. What we will get? AX plus B into e power minus x plus 3. So, this is the solution for the given differential equation. Ax plus b, see Ax plus b e power minus x plus 3. Option 4 is the right option for this problem. We will move on to the next one. We need to find out the particular integral for the given function. To particular integral, we need to use the RHS. RHS is of type exponential type. Then divided by f of d is the given term, d square plus 16. Then replace d by coefficient of x, d by minus 4. So, minus 4 the whole square we will get e power minus 4x minus 4 the whole squared. We will get 4 squared only. 4 square 16 plus 16. So, 16 plus 16 what we will get? E power minus 4x by 32. So, this is the particular integral for the given differential equation. So, e power minus 4x by 32, that is option 3 is the right option. We will move on to the next one. Particular integral for the given function. So, to find out particular integral, what is the first term? Use the RHS. RHS divided by this term, d squared plus d plus 1. Whenever it is see, RHS is of type sine function. So, whenever sine function come, we should replace d squared equal to minus alpha squared. So, what is alpha? Sin alpha x, alpha equal to 2 here. So, should be very careful, this square root only for the alpha alone, not for the minus sign. So, d squared equal to minus alpha squared equal to minus 2 squared. So, minus 4. So, d squared equal to minus 4. So, substitute here sin 2x divided by minus 4 plus d plus 1. So, what we will get? Sin 2x by minus 3 plus d or d minus 3, right? I will write like this, sin 2x by d minus 3. So, what is the next step? We need to multiply by d plus 3 divided by d plus 3, okay? The conjugate of this one, not conjugate, the d minus 3 whenever comes, we need to replace by multiply both numerator and denominator as well by d plus 3. So, when we multiplying, what we will get? Sin 2x into d plus 3 divided by d squared minus 9, okay? Then we need to substitute d squared equal to minus alpha squared here. Alpha is nothing but 2 only. So, d squared equal to minus alpha squared equal to minus alpha squared, what is that? 2 squared 4 minus 4. So, d squared by 4. So, sin 2x by into d plus 3 divided by 4 minus 9, minus 4 minus 9, sorry, minus 4 minus 9 we will get minus 3, 13, right? So, let it be. Then what is the next step? Differentiate d. When we differentiating this term, what we will? Sin 2x we will get cos 2x into 2. Then it is just a constant plus 3 sin 2x in the denominator minus 13. So, this is the particular integral for the given differential equation. So, here see they are separating, see this one. So, are you able to correlate? Okay, minus 2 here, multiply by minus 13, they are separate, minus 2 cos 2x by 13, again minus 3 sin 2x by 13, okay, according to the option 3 is the right option, okay. We will move on to the next one, particular integral for the given function. So, what is the first step? To find out the particular integral, we need to use the RHS. See the RHS is nothing but type cosine function. So, divided by f of d squared minus 4d plus 4. Then for a sine function and cosine function the procedure is same. So replace d squared equal to minus alpha squared. What is alpha here? 2 squared minus 4. So d squared equal to minus 4. Just substitute minus 4 here, minus 4 here. Okay, minus 4 minus 4d plus 4. So this and this get cancelled. What we will get? Cos 2x by minus 4d. So minus I can write like this, right? Minus 1 by 4 into 1 by d into cos 2x. So 1 by d represents differentiation. See, d represent differentiation or d by dx. 1 by d represent integral dx, integration. Okay, so we need to integrate this term. So integrating that, what we will get? Cos 2x sin 2x divided by 2. So minus 1 by 8 or minus sin 2x by 8. So this is the particular integral for the given differential function. So minus sin 2x by 8. Option 2 is the right option. We will move on to the next one. Solution of the differential given function. So solution means we need to find out the both complementary function and particular integral. Okay, first we will find out the complementary function. For finding out complementary function, we need to assume RHS equal to 0, f of d into y equal to 0, f of d is nothing but d square plus 4, okay, equal to 0. Then form the auxiliary equation. Auxiliary equation is nothing but just replace d by m squared plus 4 equal to 0, m squared equal to minus 4. Then what is m? This is complex conjugate plus or minus 2i. So here roots are complex conjugate. So this is of the form of alpha plus or minus I beta. Here alpha equal to 0, beta equal to 2. Alpha is 0 na, beta equal to 2 here. So whenever roots are complex conjugate, how to form the complementary function? So e power alpha x, e power 0x into a cos beta x. Beta here 2x plus b sin beta x. b sin beta is 2, b sin 2x. So e power 0x we will get 1 only. So a cos 2x plus b sin 2x. This is the complementary function. So it is the equation 1. Then what is the next step? We need to find out the particular integral, and clubbing both complementary function and particular integral, we will find out the solution. Okay, then find out the particular integral. For finding out the particular integral, we need to use the RHS. So RHS is of the type of sine function. So sine function divided by f of d square plus 4 here. Okay, so for sine function just replace d squared equal to minus alpha squared. What is alpha here? 2 squared minus 2 squared, we will get minus 4. Okay, so d squared equal to minus 4 sin 2x minus 4 plus 4. We will get some numerator term divided by 0. Whenever we will get, it is absurd. So we should use one shortcut. What is that? Multiply by x in numerator and differentiate denominator. So this term, see, so PA equal to multiply by x, nothing but x sin 2x, then differentiate denominator, we will get 2d. Okay, 2d. So it is very simple. So x by 2, it is nothing but differentiating this term sine function, right? Sorry, not differentiating, denominator 1 by d, which means that it is integration. So integrating that, what we will get? X by 2 into integration of 1 by d into sin 2x cos 2x minus cos 2x, right? So minus cos 2x divided by 2. So the what is the particular integral? minus x cos 2x by 2 into 2, 4. So, it is a equation 2. So, y equal to, what is that? Y equal to CF plus PA. Adding integral 1 plus 2. What will get? A cos 2x plus b sin 2x minus x by 4 cos 2x. So, this one a cos 2x plus b sin 2x minus x by 4 cos 2x is the right option for this problem. Okay. So, this is the right option, option 4. 4 is the right option. We will move on to the next problem. We need to find out the particular integral for the given problem. So, particular integral, we should see the type of RHS. Type is nothing but cosine function divided by d squared plus 16. So, we need to replace a d squared equal to minus alpha squared. What is alpha here? Minus 4 squared. Okay. So, d squared equal to minus 16, right. So, write cos 4x by minus 16 plus 16, we will get in denominator part, we will get 0. So, whenever 0 comes, we should do one thing. What is that? Multiply by x in the numerator and differentiate denominator. So, do this here. So, pi equal to multiply by x 4x divided by differentiate denominator is nothing but 2d. Okay, we will get 2d. So, what is the next step? X by 2 into 1 by d of cos 4x. 1 by d is nothing but integration. So, whenever integrate, what we will get? X by 2 sin 4x by 4. Okay. So, x sin 4x by 8. So, this is the particular integral for the given differential sum, x sin 4x by 8. So, x sin 4x by 8, option 2 is the right option. Okay. We will move on to the next problem. We need to find out the solution for the given differential equation. So, we need to find out the solution for the given differential equation. Solution means we need to form both CF and PA, complementary function and particular integral. What is that? So, complementary function, to find out complementary function, this is f of d into y. Assume RHS equal to 0. So, then we need to find out the form the auxiliary equation. Auxiliary equation is nothing but replace d by m squared plus 4, right hand side equal to 0. So, then whenever finding out root, what we will get? Plus or minus 2i na. We have two roots. See the roots. Roots are complex conjugate. It is of the type of alpha plus or minus I beta. So, alpha equal to 0 and beta equal to 2 here. So, roots are complex conjugate. What is the complementary function? E power alpha x, e power 0x into a cos beta x, a cos 2x plus b sin 2x, b sin beta x, again b sin 2x only. So, e power 0x we will get 1 only. So, nothing but a cos 2x plus b sin 2x. So, this is the complementary function. See, it is a equation 1. Then, we need to find out the particular integral. So, to find out the particular integral, we need to use the RHS. See, the RHS is of type sine function, see, sin 3x divided by the f of d, nothing but d squared plus 4. D squared plus 4. Whenever sine function come, we need to replace d squared equal to minus alpha squared. So, alpha here is 3, 3 squared equal to minus 9. So, d squared equal to minus 9. So, sin 3x divided by minus 9 plus 4. What we will get? Sin 3x divided by minus 5. So, this is PA. Say it is a equation 2. Then what is the solution? Y equal to CF plus PA. So, adding these two equations, so a cos 2x plus b sin 2x minus this minus sign sin 3x by 5. So this is the solution for the given differential equation. So option 3, a cos 2x plus b sin 2x minus sin 3x by 5. We'll move on to the next one to find out the particular integral for the given function differential equation. So we need to use particular integral, which will see RHS is of sine type divided by this term d squared plus 4. So we need to use d squared equal to minus alpha squared, here alpha equal to 2 squared, we will get minus 4. Okay. So d squared equal to minus 4. So 2 sin 2x by minus 4 plus 4. We will get numerator part divided by 0. Whenever denominator, we will get a denominator as 0, what should we do? We do one simplification or shortcut. Multiply by x in the numerator and differentiate denominator. So this thing. So 2x sin 2x divided by differentiate denominator 2d. Okay. So 2 and 2 get cancelled. Then here what is remaining? X into 1 by d into sin 2x. So sin 2x 1 by d represents the integration. Okay. Integrating sin 2x, what we will get? Minus x cos 2x sin 2x minus cos 2x. So minus x cos 2x divided by 2. So this is the particular integral for this type. Minus x by 2 cos 2x. Okay, minus x by 2 cos 2x. Option 2 is the right option. We'll move on to the next one. Solution of the differential equation, given differential equation. So solution means we need to find out the complementary function and particular integral as well. First we'll find out the complementary function. To find out complementary function, this is f of d into y. Assume RHS equal to 0 to find out the complementary function. Then to form the auxiliary equation AE, just replace a d by m square plus 1 equal to 0. Then finding out the roots, m equal to plus or minus I, right? M square minus 1 equal to 0. When we finding out factors, this the one. See the roots are complex conjugate. So alpha plus or minus I beta. Here alpha equal to 0, beta equal to 1. So what is the complementary function? E power alpha x 0x into a cos beta x, beta equal to 1, a cos x plus b sin beta equal to 1, b sin x. So CF equal to a cos x plus b sin x. So it is a equation 1. Then we need to find out the particular integral. Particular integral, we need to see the RHS. Whenever RHS is x term, what should we do? We will see d. So x divided by d squared plus 1. This is the first procedure. See, the RHS is of type of x. So RHS is of type x. We should do 1 plus d squared. Just I am rearranging 1 plus d squared. Then when it gets goes to numerator as 1 plus d squared whole power minus 1 into x, right? So this is of the form of 1 plus x the whole power minus 1. So what is the shortcut? What is the series? 1 minus x plus x squared minus x cube plus up to infinity. Okay, so this is the shortcut. Okay, we have clearly explained all this in our previously we have posted many videos. Kindly check. Okay, so just expand this series. 1 minus x. Here x means this term. Whatever in this place, we will assume that is a x. So 1 minus x. So 1 minus d squared plus x squared. X squared means d power 4. We will stop up to this because we are having this term only, x only. When we differentiating x up to above 3 times, we will get only 0. So we will stop up to this. So 1 minus d square plus d4 into x, just multiply into this, what we will get? X minus differentiating double term. Differentiating double the time, what we will get? 0. Okay, d square. Here differentiating 4 time, differentiating at that is also 0, so it is x alone. So PA equal to x alone. So it is equation 2. Since then what is the solution? Solution equal to complementary function plus particular integral. So adding equation 1 and 2, a cos x, this one, plus b sin x plus PAX. So this is the solution for the given differential equation. So a cos x plus b sin x plus x, option 1 is the right option. Okay, we'll move on to the next problem. So we need to find out the particular integral for the given function. So should use RHS. See, the RHS is of type x. Okay, so divided by f of d square plus 3d plus 2. Whenever this comes, what should we do? We should do we should form 1 plus x or 1 plus that term. So we will take the constant outside, okay, d 2. When we take 2 outside, what we will get? 1 plus this 3d, I am just real 3d plus d square divided by 2. Can you get? I am just taking 2 outside, so then 1 plus 3d plus d squared by 2. So this is of type 1 plus x form in the denominator. So this is a x. Okay. So next, what is the next step? X squared by 2. So these two terms, leave it alone. Then 1 plus 3d plus d squared by 2. Okay, whole power minus 1, taking to the numerator. Okay, whole power minus 1. So we will know the expansion of 1 plus x the whole power minus 1, 1 minus x plus x squared minus x cube plus etc. up to this. Just consider x as 3d plus d squared by 2 here and then expand this series. Okay, then see x squared by 2, then 1 minus x. Okay, 1 minus x means minus of this term 3d plus d squared by 2, then again plus, alternatively minus plus sign, then this term the whole squared, x squared now. So 3d plus d squared by 2 the whole squared. We will stop up to this. Okay, up to x squared is enough. Whenever we are doing this kind of problems, we will stop up to this 1 minus x plus x squared, up to power 2 is enough. Okay, then we'll need to cross multiply inside. Okay, x squared by 2. So or 1 by 2 will be in the outside, or okay, 1 by 2 will be in the outside. Just multiply with x squared, then this term minus 3d by 2, 3d by 2 x squared, differentiation of x squared, what we will get? 2x. Okay, here I am writing, I am using this, okay, to avoid confusion. Okay, I am writing here. Okay, 3d by 2 into x squared. So 3 differentiation of x squared, we will get 2x divided by 2. So what we will get? 3x. Okay, here 3x now. So I am getting minus 3x, then here also minus sign, x squared. So d squared by 2. So double time differentiating. Whenever differentiating one time, we will get 2x. Otherwise next time we will get 2. Say then 2 by 2 only. So here our denominator also 2. So minus 1. Okay, minus 1. Can you understand the simplification? Okay, then this is the whole square. This part is over. Then plus, we need to multiply by x with this term. This is a plus b the whole square term. Whenever differentiating, we will get 3d power this term only. See, a plus b the whole square. A squared means 3d squared plus b squared d power 4. D power 4 differentiating 4 times this term will get 0 only plus 2ab. 2 into this and this we will get d cube. So differentiating third time we will get 0 only. So we will stop up to d squared only. So I am not going to expand this up to 3. So this term only, a square term, what is that? 3d squared plus 2 into that x squared. I am writing here, okay, for our understanding. So remaining term we no need to expand because we will get 0 only, okay. So half is in the outside, x squared minus 3x minus 1. Then again differentiating 2 times, okay, 2x we will get 2. Again we will getting 2. So these 2 and these 2 will get cancelled. Then plus minus 1 plus 3. Okay. Then x squared so 3d is nothing but I am just squaring the d alone. So 3d by 2 the whole squared, what we will get? 9d squared by 4. Here I have done a mistake, 9d squared by 4. So double time differentiating we will get 2 alone. So 2 and 2, so 9 by 2. Here 9 by 2. So 9 by 2 we will get minus around 7 by 2. So okay, 9 by 2 to minus 2 plus 9 we will get plus 7 by 2. So x squared minus 3x plus 7 by 2. So this is the answer, half into x squared minus 3x plus 7 by 2. Here I have done a mistake, like not 3d squared by 4, this is 9d squared by 4. So double time differentiating we will get in numerator as 2. So 2 here 2 and 4 get cancelled. So 2 alone. So 9 by 2 here. So the answer is half x squared minus 3x plus 7 by 2. 3 is the right option for this problem. We will move on to the next one. See. So particular integral for the given function. So particular integral we need to use RHS is the x function. So divided by d square minus 4. Whenever x function comes we should replace as is 1 plus x. So like this, 1 plus x. So for that what we need to do, take the constant outside, x squared by 4. Whenever taking 4 outside or minus 4, take minus 4 outside, we will get 1 minus d squared by 4, right? We should correct, minus into 4 minus 4 minus into minus plus again plus d squared. So taking constants, this is of type 1 minus x, okay, form. So this will go to the numerator, minus 1 by 4, and this is x squared. What is in the numerator? 1 minus d squared by 4 the whole power minus 1. So this is of 1 minus x the whole power minus 1 format, okay. So what is the expanded term? 1 plus x squared plus x cube. So should be very careful in this sign. Whenever here both are minus sign, we will get only positive signs. When for 1 plus x, previously seen na, here 1 plus x now. So for 1 plus x the whole power minus 1, we will get alternatively positive or negative signs. So whenever both are negative, we will get no sign changes, only positive terms only, okay. So we should very clear about the expanded time. So expanded terms. So just expand these term, okay. Minus 1 by 4 into x squared into just expand this 1 plus x is nothing but d squared plus 4, up to x squared we will stop. Then this term the whole squared, okay. Then d power 4 by 16 we will stop up to this. Then we will proceed the further is nothing but multiply the x squared inside. So x squared inside we will get x squared plus d squared means double time differentiating. When we differentiating this, what we will get? D one time differentiation of x squared, we will get 2x. Again differentiating d squared, we will get 2. So 2. So then 2 by 4, 1 by 2 only. Then this is the 4 times differentiating, third time itself we will get 0 constant, then 4 time we will get 0 only. So we will stop up to this. Then so this is the final answer. So particular integral equal to minus 1 by 4 into x square plus half. See, minus 1 by 4 x square plus half, option 1 is the right option. Okay. Then we will move on to the next problem. We need to find out the particular integral. So particular integral is of type x type. So we will follow the same procedure like above problems. So we should rearrange this term as 1 plus something. So 1 plus something, just rearrange it. So 1 plus d squared plus 2d, right? This term 1 plus x. So just rearranging 1 plus d squared plus 2d or x squared by 1 plus 2d plus d squared, whatever it is. Okay, it is 1 plus x. Okay, format. X is nothing but 2d plus d squared. Then we'll take that to the numerator, x squared into 1 plus 2d into 2d plus d squared whole power minus 1. So it is 1 plus x whole power minus 1. What is the expanded term? 1 minus x plus x squared. This is x. 1 minus x plus x squared minus x cube, etc. Okay. So just expand this. First 1 plus x the whole power minus 1, 1 only, then minus x. X is this term, minus x nothing but 2d minus d squared. So I am just multiplying with minus sign also. Then x squared plus x squared. This x squared term we will get 2d squared, right? X squared term 4d squared. Okay. These two term 4d squared. We will stop. Okay. Sorry. I will write it very clear. This is x. Okay. To avoid confusion. So x squared into 1 plus x whole power minus 1, 1 first, then minus x term. X term is nothing but 2d plus d squared term, then plus x squared term, then 2d plus d squared the whole square term. We will stop up to the square term. Then now expanding this, what we will get? 1, this minus 2d plus d squared, let it be, then 2d plus d squared the whole squared. This is of a plus b the whole squared. A squared, what we will get? 2d the whole squared, 4d squared. Then this is a d power 4 x squared. So when we differentiating fourth order, we will get 0 only. So we'll exclude the term. No need to expand. Then 2ab. 2ab means d into d squared d cube. For differentiating third order, we will get 0 only, because x square term, when differentiating x square, we will get 2x. When we double time, again second order derivative is nothing but 2. Third order derivative, we will get 0. Then up to next order, we will get 0 only. So we will stop up to d square term only. Okay. This is the concept. Now multiplying this x squared inside x squared minus 2d. 2d minus differentiating one time we will get 2. So minus 2 into already 1, minus 2 into 2 minus 4. Then again differentiating one term we will get 2x only na. So minus 2x here, x squared minus 2x. Okay. Then double time differentiating, what we will get? 2. So here minus 2. So x squared minus 2. Again plus d squared. D squared we will get 2. 4 into 2, 8. Nothing but d squared 2. D is 2x. So I am just x squared minus 2 into differentiating one time, what we will get? 2x na. This is also 2x. So 2 into 2 4x. X squared minus 4x. Okay. D squared equal to plus 2, here minus 2, then 4 d squared value is 2, 4 into 2 8 plus 8. So x squared minus 4x plus 6, x squared minus 4x plus 6. So this is the particular integral, x squared minus 4x plus 6. So particular integral value is option 1 is the right option. So again we need to find out the particular integral for the given functions. So to find out the particular integral, this is of cosine function cos of 2x plus 3 divided by d square minus 3d plus 2. Then differentiate d squared equal to minus alpha squared. What is alpha here? 2 minus 2 squared, we will get minus 4. So d squared equal to minus 4. Substitute d squared equal to minus 4. 2 cos of 2x plus 3 minus 4 minus 3d plus 2. What we will get? 2 cos of 2x plus 3 minus 3d minus 4 plus 2 minus 2. So minus, or take minus in the numerator, cos of 2x plus 3, take minus common, what we will get? 3d plus 2. So 3d plus 2 we need to cross multiply by 3d minus 2 by numerator and denominator as well. So whenever doing this, what we will get? Minus 2 into 3d minus 2 of cos of 2x plus 3 divided by a plus b into a minus b is nothing but a squared minus b squared. So 9d squared minus 4. So again we need to substitute this term, 9 in place of d squared, substitute minus 4. So whenever minus 4 we will substitute, I am just simplifying the denominator term alone. So d squared equal to minus 4. So minus 4 is nothing but minus 36 minus 4. So we will get minus 40. Okay. Already in numerator something divided by, so minus 2 into some numerator term divided by minus 40. So I am just I don't want to repeat again these steps, so I am just solving this. Okay. So minus and minus cancel 20. So in denominator, numerator term, what is in the numerator, we will cancel these two. So 3d minus 2 pa equal to 3d minus 2 into cos of 2x plus 3 divided by 20 in the denominator. Okay. For that only I am just simplifying to avoid repeating the steps. Okay. So now multiply with the cos of 2x plus 3 inside, what we will get? 3 into differentiation of this term. Differentiation of this, what we will get? Minus 3 cos of cos x is nothing but sin x. So minus sin x. So minus I am writing here minus 3 into sin of 2x plus 3. Here 2x. In place of x, we are having 2x plus 3. Now differentiate this term. 2x is nothing but 2x, differentiating we will get 2. So minus into 2. Okay. When we differentiate, we will get minus 3 sin 2x into 3. Then minus 2 cos of 2x plus 3. This term. In denominator 20. So what we will get? Minus this term. Okay. Minus 6. Okay. In minus 1 minus, take minus 1 by 20 outside. Okay. 3 into 2 6. 6 sin 2x plus 3 plus cos 2 cos 2 cos of 2x plus 3. So this is the particular integral, minus 1 by 20 I'm just taking minus outside in the numerator and denominator 20 outside. So what is remaining? 3 into 2, 6 sin 2x plus 3 plus 2 cos 2x plus 3. So option 2 is the right option. Minus 1 by 20 in this into this term. Okay. Then d squared plus 1 into y equal to e to avoid confusion. So this is the d squared plus 1 into y equal to 0. Solve means we need to find out both the solution of differential equation is nothing but y equal to cf plus pa. We need to find out complementary function and particular integral as well. First we need to find out the complementary function. To find out complementary function, assume right hand side equal to 0. So d square plus 1 into y equal to 0. So this is function of d into y equal to 0. Then we need to form the auxiliary equation. Auxiliary equation is nothing but just replace d by m. M squared plus 1 equal to 0. M equal to plus or minus I. Right? So see, the roots are complex conjugate. So alpha plus or minus I beta. What is alpha here? Alpha equal to 0 and beta equal to 1 here. Okay? 1. So complementary function is nothing but e power alpha x, e power 0x plus a cos beta x, a cos x plus b sin beta x, b sin x. So complementary function equal to e power 0x is nothing but 1 only. So a cos x plus b sin x equal to 1. Then we need to find the particular integral. Particular integral means we need to use the RHS. RHS is nothing but E, only E divided by f of d, d square plus 1. So we can write like this, right? E power 0x equal to e power 0 equal to 1. So it will not going to affect this term. Okay, then E we are getting 0, so just replace a d by 0. Okay. Whenever exponential term comes, we should replace a d by the coefficient of x. So d by 0. Whenever 0 comes, we will get e by 1. This term will get 0. So e. So particular integral as e alone. So it is equation 2. So y equal to what is that? Complementary function plus particular integral. So cf plus pa. So y equal to a cos x plus b sin x plus e, this one. So this is the solution for this differential equation, y equal to a cos x plus b sin x plus e. So whenever e term comes, don't need to panic or no need to struck in this. We should replace e power 0x. So it is nothing but this will not going to get affect this term. So for this problem, this is the solution. Option 3 is the right option for this problem. Okay, then we will end the lecture up to this. Please subscribe our channel Off Campus and then click on the bell icon also. Then only you will receive notification whenever we upload videos. Okay, we already, I told before, we have posted many videos under engineering. Okay, if you haven't seen those videos still, kindly check with the playlist. Okay, thank you.